Hi friends, I am Uday Sagar Kanpal and I welcome you all to yet another lecture on data structures using Java on Netbeans IDE. Today we will talk about yet another data structure called queue. In last video I talked about a data structure called a stack where the first item into the stack comes out as last item from the stack. Here in the queue, as it is very obvious that the first element in the queue would be processed first and the last element would be processed last. So queue is like a queue in a picture mall when we buy tickets. So the first person coming to the counter to buy the ticket will be processed first. He will be given ticket first and then the second person and so on. So before we start, I ask all my new viewers to please subscribe to my channel and please like my video on YouTube and comment and share. Thanks. Let's begin. So first we create a class called queue. Now just like stack, it will have an array to store the data, but it will rather than having a top, it will have a head and a rear. So first define the capacity of the queue. Int capacity equals to 10. Let's make it as final and static. And let's decide the size as capacity. Now we define a head, a rear for the queue. Now just like a stack has a function called as push and pop, here the queue will have two functions called as enqueue and dequeue. Enqueue pushes the element inside the queue or enqueues the element inside the queue, and the dequeue function will remove the element from the queue or dequeues from the queue. So the first person or the first node that enters into the queue will be deleted first while dequeuing, and this is what is called as first in first out or last in last out mechanism of a queue. So let's continue with the enqueue and the dequeue functions. Public int enqueue, and we will pass an int value to enqueue inside the queue. So the condition for this would be if rear equal to capacity minus 1, in fact not equals to, but yeah, less than equals to, then we will enqueue inside the queue. So how to enqueue? So first we initialize the head as 0 and the rear as 0. Now array of rear plus plus equals to value, and we can return the index of the rear element. Else return 0, or we can return minus 1 in that case. So let's create a dequeue function. Now the condition would be if head equal to rear, or I should say is smaller than rear, int value equal to array head array head equals to 0 head plus plus, and return value or the index. In fact, here we cannot return the index, so we'll return the value. Return 0. So this is the Dequeue function. We can return anything in the Enqueue and the Dequeue function. It is not necessary because we are creating a separate print queue function to get our data from the queue. So public void print queue front to rear for int I equals to front I smaller than rear I plus plus. Here front or head, it's the same thing. We have written head, so we'll return head, and we will also rename the function as head to rear. So we can either name it as head or front. It is an internal implementation. We will not be accessing the internal variable, we will only be accessing the function, so that doesn't matter to us as of now. So int I equal to head I smaller than rear I plus plus, we will print array of I we can also show the direction of the Enqueue or the Dequeue by the arrow pointer. So if I equal to rear minus 1 s out, in the else case, now this is printed. Now let's get the implementation of the queue. So here this is our main function. We will create a queue object and we will print the queue initially. Now Enqueue 1. So initially your queue was empty and the out direction from the queue was towards the left, and the second we enqueued 1, so 1 was enqueued. We can copy paste more values till the capacity is full. So we have enqueued 10 values into the queue and we are getting 1, then 1 and 2, then 1 2 3, then 1 2 3 4, then 1 2 3 4 5, then 1 2 3 4 5 6, then 1 2 3 4 5 7, then 1 2 3 4 5 6 7 8, then 1 2 3 4 5 6 7 8 9, then 1 2 3 4 5 6 7 8 9 10. Pardon if the order is incorrect or I have pronounced anything wrong. So it is in the same numerical order 1 to 10. Now we will have to dequeue the queue and print. Now the dequeue element should remove the 1 first, then it should remove the 2, then it should remove the 3, then it should remove the 4, then it should remove the 5, because 1 was entered first, so 1 would be removed first. In stack 10 was entered in the end, so 10 was removed. Only thing is that I printed it from 10 to 1 instead of 1 to 10, so the direction remains the same, but the actual direction or the with respect to the order of insertion is reversed. So let's first try inserting one more element in the queue. Now since the value of queue or the capacity of the queue is 10, so it should not enter anything into the queue. So again the queue is printed. Queue is printing till 10, which means the capacity is fulfilled and the queue cannot enter any value. So I have now added a dequeue function and printed the queue again. Let's now run the code. So you can see 1 is removed from the queue and the queue length is reduced by 1, which means our queue is working correctly. Now we can try to remove some more elements from the queue. So guys, I have dequeued all the 10 values from the queue and it's removing correctly. Now one thing more, when again the capacity is full, we should initialize the queue to the default state. So we should do that in the enqueue function. So in the enqueue function we defined a condition: if head equal to rear, then head equal to rear equal to 0, which will reinitialize the queue. As we will enqueuing into an empty queue, it would definitely be printing 1 this time, as you can see. So this is how a queue is being enqueued and dequeued n number of times. So now let's look at the code. This is the code for the enqueue function. You can take a look. This is the code for the dequeue function. This is the code for printing the queue, and this is the main implementation. You can have as many enqueues and dequeues into this queue n number of times. Like we can see here, we enqueued the queue with full capacity, when we dequeued the queue with full capacity, and then we again enqueued a value into it. So thanks for watching my video. Meet you in the next lecture. Bye bye.